Okay, we go on with public key cryptography. In order to do that, we need a bit of algebra. So we're seeing that P, with P is a prime. Now it's time to have a look at Zn, where n is an integer. Now we can sum and multiply. However, it's not guaranteed that we have a field. We can consider a subset Zn star. Who is Zn star? Where we can take the numbers in Zn, which are coprime with n. Now, Zn star is a group. Zn star is a group with respect to the multiplication. Is a group with respect to the multiplication. The number of elements is called phi of n, is the number of elements of Zn star. This is also called the Euler function. Okay, what is the value of phi of n? Well, it has some properties. What we are interested in is the following case. When we have P is a prime, phi of P is P minus 1, clearly. And when n is the product of two primes, then phi of n is pi minus 1 q minus 1. In fact, phi is a multiplicative function. Now, an instantive feature of Zn star is the following. Since Zn star is a group with respect to multiplication, we get immediately the following theorem. We take an element in Zn star, this element to the group order, so to the group order, must be the identity element. So, writing in congruence notation, we get the following. A to the phi of n is congruent to 1 modulo n. And be careful that A must be in Zn star. So A must be prime with phi with n. Now we can see an example. So if we consider Z6, 0, 1, 2, 3, 4, 5, we have Z6. Now what is Z6 star? Z6 star are the numbers which are coprime to 6. So we have 1, not 2, not 3, not 4, 5, and not 6. Now we have two numbers, 1 and 5. Now what about phi of 6? 6 is phi of 3 times phi of 2. So with this, 2 times 1, 2. And indeed, it has the right number of elements. There are only two numbers in Z6 which are coprime 6, 1 and 5. And now, by applying the theorem, we have that 1 to 2 is actually congruent to 1 modulo 6. This is obvious. Less obvious is about 5. 5 to 2 should be congruent to 1 modulo 6. But 25 is 6 times 4 plus 1. So 25 is congruent to 1 modulo 6. So we see Z6 better. So I said that Z6 is not a field. Now, in Z6 star there is 1 and 5 that are coprime to 6. Very good. Now what is the inverse of 1? The inverse of 1 is 1. 1 over 1 is 1. What is the inverse of 5? Well, we have to look for it. 2 times 5 is 10, which is 4. 3 times 5 is 15, which is 3. 4 times 5 is 2. 5 times time is 25, which is 1. So, the inverse of 5 is 5, because 5 times 5 is 1. Now, in a field, everything which is non-zero has an inverse. So, Z6 is not a field. Let's take 2. I claim that there is no inverse for 2. So, I try all products. 2 times 2, 2 times 3, which is 0, by the way. 2 times 4, 3, 2 times 5, that 4. So all possible products, they are different from 1. There is no x, or for all x, 2 times x is always different from 1 modulo 6. So there is no inverse for 2. And that means that Z6 is not a field. On the other hand, the element in Z6 star, they all have inverses. And that's true in general for Zn and Zn star. So, in general, for the same reason, if A is in Zn star, then there is the inverse. And actually is in Zn star. As we said, it's a group. Generally speaking, theorem, Zn is a field. So we saw that Zp is a field, Phi prime, in theorem. In general, Zn is a field if and only if n is prime.